Hello everyone. Good morning to all. Today we are going to discuss about bitwise operators. So the basic bitwise operators we are going to discuss here, and what are the programming also in this C we are going to discuss here. So first one is bitwise AND operator. So here whenever we are going to queue the two inputs A and B, so the two inputs may be either 00, 01, 10 and 11. So the bitwise AND operator logic is like the output will be high if both inputs A and B are high. That means if both inputs are going to be high, that is 1, then only the output is going to be 1. In all the remaining cases, the output is going to be 0. So here we have given an example like the variable ch1 is going to be taken in hexadecimal value 86, which is represented 8 with 1000 and 6 with 0110. And similarly the another variable ch2 hexadecimal value is 9b, so which is represented with in hexadecimal representation 1001 and 1011. So whenever we are going to do AND operation here with these two variables, we are going to get like whenever the both inputs 1 1 is there, then only I am going to get 1 as an output. In all the remaining cases, the output is going to be 0. If we are going to see the result, only the bit position 1 is going to be 1 1 is there, and the bit position 7 it is going to be 1 1 is there in both the inputs. So therefore I am going to get the hexadecimal output as 0x82. So this is the bitwise AND operator. The second operator is bitwise OR operator. Here the logic is if any one of the input is going to be high, the output will be high. High means here it is 1, low means it is 0. So here I am going to have 0 0 0 1 1 0 and 1 1. These are the four cases what we are having. So except the case 0 0 where the output is 0, because the both in both the inputs the input is not going to be 1, but in another cases at least one of the input is going to be 1, and if both the inputs are also going to be 1, the output is going to be 1 here. So this is the example what we have given, the same example where wherever the both the inputs are 0 0, then only the output is going to be 0. If at least one of the input is going to be 1, that is high, the output is going to be high here. Next, bitwise XOR operator. So the here the output is going to be high if both inputs are going to be different. That means if one of the input is 0, the other input is going to be 1. That means both are complement to each other. And in the remaining cases, if both the inputs are both low, that means 0 0, and both the inputs are 1 1, that is high, in those cases the output is going to be 0. So that's what in the representation we have given here. And bitwise complement operator, so here if we are going to give the input as low, the output is high, that is 0, the output is 1. If the input is high, that is 1, the output is going to be low, that is 0. So that is what bitwise complement operator. So here is an example what we have been given here. And the next operator is bitwise left shift operator. So this bitwise left shift operator we are going to use most often in the bitwise operations in C programming, and it is also used in embedded C programming. So this is very important operator. So the bitwise left shift operator shifts the bits of a binary number to the left by a specified number of positions. That means how many number of positions we want to shift that particular binary value, we can able to give that number over here. Suppose, and also it is going to be multiplies the given number by a powers of 2 corresponding to the number of positions. So how it is going to be, let us see here. So the syntax is x less than number of positions. X is left shifted by number of positions, it is not less than, it is x left shifted by number of position. So the result is going to be equal to what, whatever the x value is there into 2 power number of positions. That means how many number of positions we have given, that many times 2 power it is going to be multiplied. So let us see how it is going to be. We have taken a variable ch equal to 0 8, and it is represented like this 0 0 0 1 triple 0. So this is the decimal number 8, it is going to be represented, and the hexadecimal value also we are going to be represented as 0x08 for the same number. And how we are going to calculate this decimal value. So whenever a particular number is there, as it is a position 0, that is least significant bit, it is going to be multiplied by 2 power 0. Similarly, the next bit, it is going to be multiplied with 2 power 1, 2 square, and the next bit, third position, it is 1, so 1 into 2 cube, it is going to be there. So here we have a cross marker that is as 0 into 2 cube, but it is 1 into 2 cube. uh, it needs to be modified over here, and remaining all the places it is 0 only, so therefore it is going to be 0 I am going to get. So finally I am going to get 1 into 2 cube, that is 8 here. And the next positions, if you take suppose I have given 8 left shifted by 2, so the result is going to be 8 left. Result 1, if we are going to see here, result 1 is ch left shifted by 1 position time, and result 2 is ch left shifted by 2 position times. So let us see what will happen if I will shift the 8 value by 1 position. So whenever I am going to left shifted by 1 position, so see here, this is the ch value, 8 is the ch value what we are having. The second one, ch is left shifted by 1 position I am going to have here. So whenever 1 is left shifted here, what will happen, the most significant bit which is at 7th position, it will be left shifted, so that that bit is going to be lost. Similarly, the 6th position will come to 7th position, 5th position will come to 6th position, and 4th position bit 0 is going to be come to 5th position here, and the third position which is 1 in 8 number, it is going to be come to 4th position. And similarly, second position will be shifted to 0, that is third position, and 1 is going to be shifted to second position. Sorry, that is 0 is going to be shifted to second position, and the bit position 0, it is going to be shifted to 1 position. So that is 0 is going to be there. Whatever it has been left over, it is there, it is going to be filled with 0 over here, so that I am going to get 16 here. Why? Because why 16 I am getting here, 1 now it is shifted to 4th position, so therefore 8 into 2 power 1, so I'm going to get how many, it is going to be 16. So why? Because it has been shifted by one time. So if we are going to take the hexadecimal value here, the hexadecimal value is going to be 10 here. So whenever, so that means what, the 8 value is being converted into 16 when I have been shifted that particular number by one time. Similarly, if I am going to shift it by 2 times, then what will happen, the fourth bit position 1 which is in 16, it is going to be come to 5th position in the second time whenever we are going to shift. So therefore I am going to get 32 value as an decimal value, 8 into 2 square. So why? Because the result is going to be value into 2 power number of positions. So as it is shifted by 2 times, so I am going to take the power as 2 here, so therefore it is going to be 32, and whatever the hexadecimal value it is there, it is going to be 20. So this is about the bitwise left shift operator. So the only thing what we will consider in the left shift operator is, whenever we are going to shift that particular number by one time or 2 times, the result is going to be whatever the value we are going to be shifted, it will be multiplied with 2 power how many times we are going to shift that position. Okay, so next, bitwise right shift operator. So the bitwise left shift operator, it will multiplies the particular number by a powers of 2, whereas the bitwise right shift operator will divides that particular number by a power of 2. That is the only difference between left shift operator and right shift operator. So here there are two types of right shifting. One is unsigned right shift, where it is going to be replaced, the MSB bit is with 0, whereas the signed right shift, where the MSB bit is replaced with 1 over here. So here we are going to see the unsigned right shift operation, where the value 8 is going to be represented like this, 0001000. And if I am going to right shift that 8 by one time, so then we will see that the particular bit position 7, which is 0, particular bit position 0, which is there as 0 here, it will be moving out from that particular position, and the remaining bits and all, it is has been left shifted by right shifted by one time, so that the whatever the bit position it is there, it is going to be replaced with that means the bit position 7, it is going to be replaced with 0 over here, so that I am going to get the value as 4 here. So this is the decimal value of 4 what we got if we are right shifting the value 8 by one time. Similarly, whenever we are right shifting that value by second time, then the value 1 it is going to be right shifted to first position. So therefore the most significant bit again it is replacing with 0. Why? Because it is an unsigned right shift operation. That means positive value right shift operation, where the MSB bit is replacing with 0. So here I am going to get the value as 2. So the final conclusion what we got is here, whenever the right shift operation is going to be taken place, the bit position 7 it is going to be replaced with 0, and the value will be divided by 2 power number of times we have been shifted. Similarly, we are having signed right shift operation. Here the value minus 56 we have taken, so we have to convert that minus 56 into negative, that means a binary representation. So I have taken a 56 value, I have been divided with 2. So 228 56 the value 0 will come, 2 14s 28 the remainder 0 will come, 2 sevens are 14 the remainder 0 will come, 2 threes are 6 the remainder is 1, 2 ones are 2 the remainder is 1. So whatever the representation we are having, that is we have to take from the bottom to top, that is 1111000, that is the binary representation is triple one triple zero. So this is what we have taken here, triple one triple zero, and the most significant bits are 00. This is the binary representation of 56. Now we have to convert into 2's complement value. So the 2's complement value is what? 1's complement plus 1, that is 2's complement. So therefore I have converted that 1's complement value, that is the zeros are replaced with 1 and 1's are replaced with 0, and I have added 1, then the 2's complement value we are going to get it as 11001000. This is the binary representation of minus 56. So that minus 56 what we have been done, we have been right shifted by one time, so that we are going to get this particular number, and this bit position 0 it is going to be removed from that particular representation. And see here, the most significant bit is replaced with 1 over here. And similarly, whenever we are shifting by two times, again the second time, again the least significant bit whichever 0 is there, it is going to be removed from that particular bit position, and again the MSB bit is going to be replaced with 1 in the bit position 7. That means here in the signed bit representation, that is signed right shift operation, the most significant bit is replaced with 1, whereas in unsigned right shift operation the most significant bit is replaced with 0. This is what we are going to consider, and whatever the numbers we got, that is it is going to be minus 28 and minus 14 whenever we are right shifting by particular number of times. So if you see this, minus 56 divided by 2 is minus 28, and minus 28 by 2 is value is minus 14. So this is the representation what we are going to get in the signed right shift operation. So this, and one more thing, the main important note in the operations is right shift or left shift operations, the number of shifts should be positive, and the number of shifts should not exceed the width of that particular value. So this is what we have to consider whenever we are doing either left shift operation as well as right shift operation. So this is the whole summary about the bitwise operation and or XOR or left shift operation and right shift operation. And in the next video we are going to see how to write the C programming by using these bitwise operations. Thank you.